The camera person, would you like us to start? Okay.
I think we're good to go.
Yeah. Right, great. Thanks everyone for coming. First slot after lunch. You know, if you weren't feeling asleep before, we'll help you along. See how you go.
We're going to do jumping jacks or something? Keep everyone some exercise.
My name's Christopher Hunt. I work at Typesafe and on the Conductor team. Conductor's our new product. We'll talk about a little bit about Conductor today as well, but primarily we're going to be talking about microservices. And this is Ed.
Ed Callahan here, also at Typesafe. One of the many things I've done is worked with Conductor now and helped see it to get to GA recently. So it's been really exciting.
Yeah. But again, you know, the conversation today is not really primarily about Conductor, although, of course, we want you all to go out there and buy it. But it's really about developing microservices. You know, there's been a lot of conversations, I think, out there on the internet and at conferences about microservices. And I've personally found them to be a conversation, mainly just a conversation. You know, and I've wanted to see code. You know, who wants to see code for microservices? You know, like real stuff.
Right,
yeah, okay.
Yeah.
This is what we're here for. We don't talk about it, we do it.
We do.
Yeah. All right. So, we love terms, of course, in our industry, and we love overloading them. And, of course, microservices is getting some bandwidth in that regard right now. So we thought we'd overload another one on top of microservices in the form of reactive microservices. But what do we mean by that, Ed? What do you think we mean?
Well, I guess there's the tenets of the Reactive manifesto, of course. And one of the things we're bringing here today is that the resiliency and elasticity needs to go all the way down, right? So as developers, we do the message-driven part. But if the actual deployment isn't resilient and elastic, that limits the goodness of what we've done in our programs to be realized. And as defined, that, you know, it's going to be responsive and under a varying workload and in the face of failure, because let's face it, failure definitely happens, and we have to be able to deal with it. I think in short, I kind of think of it as the manifesto is for both developers and operations, and you have to have that in order to have a successfully reactive deployed application.
Cool, yeah, and you know, particularly resiliency. You know, if you look at the Reactive manifesto, while operations may care about all four traits of it, I think resiliency kind of stands out like a sore thumb for them. You know, their charter in business is to keep the business running, right? You know, it's what it's all about. So this is why we think, in particular, the resiliency aspect of the Reactive manifesto is applicable to operations. You know, we want them to embrace this in the same way that developers have also embraced it as well.
But I'm sure no one here has an application running a single instance.
With a single DB?
Yeah, no.
I'm sure.
No,
you guys, you must be like running a cluster of databases, multiple instances.
Right.
Yeah?
Yeah, see?
All right, come on, let's have a guilty show of hands. Who's running a single instance of their DB in production? Right. I reckon there's a few more of you. I see this a lot, you know, so maybe you're not using a database. All right. Okay. So we have an example problem domain that we hope is familiar.
Yeah, pretty standard. We're going to be dealing with customers. Everyone likes customers, right? Yeah, okay, good.
We do. Do you want to become a customer? Yeah, anyway.
Well, we'll just do create and receive because, as we learned this morning, you know, update and delete are dead, so we're not going to worry about those today. And we're going to persist to a data store, right? And I mean, especially in containerization, we seem to be at this point where we've kind of containerized things, and that's great. And somewhere I got to persist all this, right? And we're kind of getting there, but we need production-grade stuff today. We can't wait for some of these things that are coming along to be ready. And of course, caching is important, right? I mean, we've all realized that going to the back ends can be expensive, no matter how fast it is. So we want to definitely have cached up front because we want to be responsive as well.
Right.
So. Pretty straightforward problem. Yeah.
So a fairly narrow focus, you know, which is really, you know, what microservices are all about. You know, it's not necessarily a single...
Uni-services.
Well, right? You know, there are so many variations on this topic. But, you know, personally, I like the narrow focus, you know, of something. It's nice and ambiguous still, right? Okay, so, yeah. Should we do it?
We've got 5 minutes.
We're going to show some code.
Do it up, man, yeah.
All right. So what I want to show you here is what we think is, you know, it should be fairly sort of typical then for a microservice like this. This is a Play 2.4 app. It's using some of the latest features, including dependency injection over here. And what we do is, in fact, inject a customer service. I can't say Pojo anymore, can I? All right, but that kind of thing. Something that's abstracted from the concerns of, what protocol is being used to, deliver requests in the first place. So the controller is all about marshalling our HTTP concerns into our domain concerns, fundamentally. All right, and we have here, we're using action async, of course, which you all should be. Never do stuff synchronously unless unless of course it's going to return immediately. But in this case, we're getting from the database, we're getting customers, with a timeout of 2 seconds. Naturally, we would use configuration to supply that timeout. We wouldn't do that explicitly. And then with the result of that, we get a sequence of customers, and we map those, we transform those into their JSON counterpart. Similarly, for an insert, we extract the name from the request over here, and then we call upon our customer service to insert that customer, providing the name, and then with the returned ID that's been generated for us, we return that, we marshal that into JSON. Okay, so that's that bit, and then we can have a look at our customer service itself. I wonder if I can do something about this screen. There we go. Our customer service is it provides these two methods, as we just discussed, and uses, from an implementation point of view, we're going to use an actor. But that concern does not leak out of this service to the controller or anywhere else. It's contained within. Okay, so to that end, what we do is we establish the actor during the startup of this, the instantiation of this class, and we then call upon it using Akka's ask pattern. If you're not familiar with that, it's effectively, as a means of returning a future, to implement request reply style semantics. And then customer service state itself is our actor. And when we start up, we call it customer service state because we're going to hold all of the customers that we've previously found, which is potentially an expensive operation. That is our state. That's the one piece of state that we're managing in here. And then so on startup, we basically go and refresh our cache, and we have a receive handler. Here, we handle get customers, and we simply return our representation of customers that's been retrieved. And then when we insert our customer, we insert through a customer repository style of thing. If you're familiar with DAO and repository style of patterns, the difference there being, that is a bounded context associated with repositories, and that's why we use them. And whereas a DAO can, actually work at a finer level of granularity. So it's all about bounded context, which of course we strongly associate with microservices nowadays. We map the ID and then pipe it to sender. That sends it back to the sender. And then what we do after all of that is refresh the cache, okay? Because our cache is now invalid, all right? And then the business of refreshing the cache is to call upon the customer repository. And with all of the customers in there, we pipe that to ourselves, and then you can see here we come into a different state. All right, that's that. And then if we look at our customer repository itself, again that's injected over here. Then I don't need to get into the internals of Slick. It's not going to be a tutorial on Slick at all, but again, we want to make this fairly sort of representative of a typical microservice in our world. So that's pretty much the architecture of that. The only other one, if we look at the routes file, then it just shows you how those requests indeed map to the controllers. So should we have a look at it running, perhaps?
Absolutely.
Okay, so I've got a little database running somewhere else, and I can, so we don't have to worry about where that runs right now. Let's start up our little service. Okay, and then we can connect to that over here on port 9000. This one's going to be. Okay, let's just do this. Localhost port 9000 / customers. This is going to actually give us that list back. All right? So no magic. This is all pretty real.
10 customers. All right.
All right. And then shall we insert into the database perhaps just to show that we can actually do this?
No, that'll work, right?
It's kind of pointless if you can't create them. Okay. And then we're going to pass here a JSON payload of the name, and we'll put ed in there. You can't have too many eds around. Pass the content type, and off we go. All right. And then we see, oh, I don't think actually that did sort of go. All right. Okay. We won't dwell on that. All right, but that's pretty much the nature of its behavior. Okay.
Forgot to bribe the demo gods, apparently.
Yeah, can someone do that? Some incense, please?
They wouldn't let me bring it on the plane.
All right. So that describes the service. Let's get back to our slides here.
Congratulations on your microservice.
Yeah, thank you. We've got a microservice. We're good now. We can all go home, right?
Time for beer.
It's fantastic. You know, we're like 11 minutes into this thing, and
that was easy.
Yeah, I mean, I know we said 5 minutes, but you know, if you actually talk about Jupiter's Day or something like that, you know, I think it works out about the same. So we didn't actually qualify it with the zone. All right, but is it?
Yeah, I think we could ask the question.
Yeah, we don't think it is.
You know, right, because back to this real world scenario, what, I don't even think it's if, it's when the database node fails, what happens then?
Right.
And, you know, how do we scale this out, both the front end, the customer service, as well as the Postgres back end, right? And if we start to scale out to multiple nodes, we've got this cache to maintain, right? So if we start inserting into one, and how are we going to handle all this?
Yeah. Have any of you tried managing distributed caches? A little bit, right?
Is it fun?
No.
Exactly.
No. And of course, you know, it's more machinery in your world, you know, something else to sort of maintain as well, right? But nonetheless, we need to deal with that problem. You will have multiple instances of your service running. And indeed, often today we don't, because this problem's hard. Okay? So I think we might have a solution though, Ed. What do you think?
I think we can. I think we can do this. So we're going to introduce Postgres BDR, bi-directional replication. And so that's a production-grade Postgres. And in this project here, you've just bundled it up, right? So it's really nothing changed to Postgres, but we've taken production-grade Postgres cluster service, and we've bundled that up to deploy on Conductor, which we'll also do with our customer service, so that we'll be able to leverage the features of that. And then for our cache situation, we're going to use the akka-data-replication, thank you, Patrick, to do a signaling so that we can update our cache and have all of our front-end nodes properly update their cache as customers get inserted. Cool.
Has anyone used Postgres BDR at all? Familiar with it? Okay, so we're talking about box standard Postgres with cluster abilities on top, and hence the BDR, bidirectional replication. So it is a flavor of Postgres. It does not come from us. It is out there. It's available as a download. There is commercial support for it. You know, so if you are thinking about running Postgres in production, this is something that you might look at, I would suggest. You know, similarly, MySQL has clustering options. You know, but I can tell you, it's a minefield out there. You know, these things are not built for clustering by default. You know, and so you may also consider, therefore, Cassandra or Reactive or whatever, you know, to manage this world for you. But for the purposes of familiarity, we thought we would stay in the realms of Slick and SQL, and you know, because this is where most people sort of play nowadays, right? So that's the outline of our solution. We should talk a little bit about Conductor as well, what that's all about. So this is not a presentation on Conductor at all, but you might be going, oh, where does this kind of fit in and stuff? So do you want to just say a few words?
Yeah, sure. You know, to me, one of the key things that Conductor does is it simplifies the jobs for the operation guys, because I build a cluster of Conductor nodes. instead of installing Netty, the operating system, in my application, and then trying to cluster a bunch of these instances into something resilient. I just build a cluster of conductor nodes, and then I deploy my application to the cluster. Kind of like the way I would deploy my standard WAR file bundle to a Tomcat server. I create these.
Did you just say J2EE?
No.
No, we're not J2EE.
No. I didn't say that.
No.
But
we're not J2EE, by the way, just so you know. All right.
But the analogy of that bundle you've created.
Managing its life cycle, right?
Managing its life cycle,
yeah.
Exactly.
That was a big promise of servlets, indeed, wasn't it? You know, that you could, have many servlets running in your Tomcat container, or just ran on a single machine. Clustering came much later, But fundamentally, it was about ops being able to manage the life cycle of those servlets, within it. What happened was that there's this one-to-one relationship between Tomcat, typically, and the servlet. And you generally don't run more servlets in that container. It's kind of like, oh, what's the point, right? So that's the most typical deployment topology of a servlet-based app today, I would argue. So we wanted to do something different here. So Conductor is really, as the name implies, it's about orchestrating, the life cycle of managing these applications and services across a cluster. At the end of the day, it's managing processes across a cluster. And again, to help you pigeonhole it, it's semantically equivalent, or functionally equivalent, I should say, to Mesos Marathon, and some of the functionality of Kubernetes as well. All right, so. And actually, Conductor is destined to become a Mesos framework as well. So Mesos is definitely in our sights. We have a standalone mode, and we will have a mode that complements Mesos as well. So hopefully that helps explain.
And we should point out it is a commercial product because...
Right.
Yeah,
it's not open source, yeah. Yeah, you can't go and have a look at the source code, unfortunately. We'd like you to, but anyway, yeah.
Well, it sounds good, Christopher. Go show.
Should we make our app reactive now then? Should we do it?
Reactive?
Yeah? We're not just going to talk about it, right?
They want beer or something. No,
yeah, maybe you're not interested. Yeah. Yeah, should yeah? All right, okay, yeah. Kind of like a tough audience, Wow. Right, okay, so what I'm going to do...
We should have brought the beer here.
What I'm going to do is I'm just going to... you guys don't want to see me sort of type, right? So I basically just applied the changes. But there are two areas of change to it. First of all, the customer controller itself does not change whatsoever, okay? So that's good. The customer service actually does change a little bit. The customer service class itself doesn't change, but the service state changes a little bit. Now this time we have this new message for signaling cache expiry. So we don't just expire our cache, we actually signal it. Okay, so let's talk a little bit about the use case that we're trying to solve here. So a request comes in over HTTP, it will get proxied to one of your services. You've got two running. It can go to just one. It doesn't go to all of them. Okay, so the point is that when we handle this request, when we perform this update, we need to tell the rest of the instances running in our little cluster that it's our own little cluster, that your cache is now invalidated. You should do something about that. Okay, that's the problem that we're actually trying to solve here. We've got this thing then called akka-data-replication. How many of you have heard of convergent replicated data types? Well, of course you all have, because Jonas spoke about them this morning, right? So, and of course, you've done nothing else since then but, read up the white papers and everything else that exists on CRDTs and stuff. But an interesting property of CRDTs, why they're so important, in my opinion, is because you have these very interesting data structures that, with this interesting property that they can always merge. There's never any conflict in terms of how they can merge, okay? And this is what makes them kind of interesting. And so we're going to use one. We're going to use one called a G counter. And a G counter is a growth counter. It just goes up, that's all. And when we update, when we increment this G counter, we tell the replicator, to increment it by however many, right? Let's just say 1. We just increment it by 1. Then every node that's gossiped and part of this cluster, this is akka clustering incidentally, will receive the update for that and can then do something. So we can use that then as a signaling mechanism to say that, your cache is out of date. All right? Seem fairly straightforward? So what we do then, as we start up this actor, we subscribe to this counter, right? That's just a key, it's just a string, okay? And the self just means tell us, when this thing updates. And the other point of difference then is when we insert a customer, instead of just refreshing our cache, what we now do is we signal our cache expiry, which sends another message, and that will come in here. And look at this baby here. So we update the replicator with a G counter structure. This parameter here is, what to do if there isn't a G counter instance there already. It's like how does one become established? And then here, at the end, is the operation that we perform, where we're given the G counter, which is immutable, and then we add 1 to it, and we pass that back. What will happen then, across the cluster, is that you'll get a changed event over here. And we're not bothered in the value of the G counter in this particular instance. We're just interested in the fact that it's been updated, all right? In which case then we do our refresh cache. So you can see then all of the nodes in the cluster will get this and they will all refresh their own cache. And that last bit, it hasn't changed from what it was. That makes sense so far? Okay. That's it, so, you talk about these CRDTs, oh my goodness, they must be really, really complex and everything. But they're not, they're really quite simple and they're extremely powerful. Because without that, how might you synchronize your cache across your cluster? You might use extensions to EHCache or pay for the commercial version of it, for example. You might use RabbitMQ or ActiveMQ in your infrastructure, and you've got more single points of failure in your infrastructure then and more things to manage. This is just leveraging akka-cluster. There's no single point of failure in it either. So you don't have to install extra bits into your infrastructure to get that. Okay, so, and then the last part of this, the other part that changes is in the customer repository. We actually add this line here, see if I can show you. That's a bit of an ugly line, but what it does, it inserts into the database using Slick, and then Postgres BDR has this function that you can call, and it's basically say, let me know when you're done, when the database is in a consistent state again. So what BDR gives you is the ability it guarantees that each individual node is in a consistent state, but you will get eventual consistency for the remainder of the cluster. That function there will return, from the database point of view, when your entire DB is consistent once again. Your entire cluster is consistent. Okay? That's what it does. But they are the only 2 changes, and you're going to pull me up on another one here in a second, aren't you?
You know this, yeah.
Yeah, okay. There is one more area of change in build SBT file, which I don't see. Oh, there it is, just there. Okay. And for Conductor to build these archives, we declare some settings here that are required for building a bundle. Okay, so a bundle comprises a bundle configuration file and then the components of that bundle. Typically there's just one component, but you can have many components if they need to be all together. And what we do is very, very strongly influenced by Mesos. So we specify the number of CPUs, memory, and other resources that we require. We also specify down here what the endpoint configurations are. So we're actually saying here that we're going to be using Akka Remote. It's a TCP protocol. Go and allocate a port for us so we know we don't clash with anything else that's running on that machine. And then, our web endpoint is what it was before, which is basically an HTTP endpoint on port 9000. And that's information there. That's information that's used for proxying. Okay, so it manages the mapping of all of this stuff. Another interesting property of Conductor, I think one thing I'm particularly proud about is that it holds this notion of when bundles have this common system property across them, you can start them in a deterministic manner. So the first one of that entire system always knows that it is the first one, and therefore can do something interesting like establish the cluster. Now, if you've used akka-clustering before, you know that you have to establish the cluster and then you subsequently specify seed nodes to join that cluster, right? Sound familiar? Bit of a pain in the bum, really, right? So Conductor takes that pain away because it provides this little guarantee. You are the first one starting, you can form the cluster, the rest of them then can subsequently join. And we did it in such a way that this can also apply to Postgres BDR and to Reactive and to Cassandra, and, the rest of them, where they all share the same property. The first one has to start, form the cluster, the subsequent ones all start and join that cluster. All right, so it's turned out to be a useful sort of trait. So that's all that you actually need to do to make it reactive. What do you want to do now, Ed?
Oh, let's run it, of course.
You want to see it run?
Oh, yeah.
Okay. This is where we have to pray to the demo gods again, isn't it? Okay, so here's one that I created earlier, as per any good cooking show. So what we've actually done here is we've created a bundle, okay, using those properties that we've just been talking about. And what we're now going to do is use the CLI command to actually load that bundle into the Conductor cluster. And you can see it's got an interesting property about it. It has this interesting hash. And we take the digest of the bundle's contents and we encode that into the name. It's fingerprinting. It's like asset fingerprinting, okay? And so that name cannot deviate from its contents. And so from an operational point of view, you always know that that thing is that thing. It's immutable. It cannot change. So, and then the other thing that you can do when you do a load of that bundle is you can associate configuration. And that configuration takes the same sort of format where we encode the digest of the config in the name. And when you load those things together, you'll return a bundle ID, and that ID will stay with the two things, that pair, forever. So as ops, that thing can be rolled back to safely. I mean, if it has other environmental concerns and stuff, you've got to deal with that, like external databases and stuff. But that thing that was working there for you before is going to work for you again before. All right? So that's the idea of that. And so what we do now then is we load that into Conductor, and then we can do a conduct info. And then what you see here at the bottom, you can see now that we've replicated it 3 times. So that means replicated, starting, and then actually running. All right? We've also got Postgres BDR in there. It's been replicated on disk, 4 places in the cluster, and it's running 3 instances of it. And then the visualizer, which is this little program I'm going to show you now, it is running here. Oh, by the way, I'm tunneling onto the machine. That's why I'm accessing it as localhost, but I'm actually going through an SSH tunnel onto the actual cluster. All right, and so what we have now, you may have seen this graphic downstairs, certainly on our booth and a few other places and stuff, but what it's showing is that we've got customers replicated here, customers replicated here, and customers replicated here, but they're not actually running yet. So now what we can do is run conductors, and we can customers, and we can specify a scale, the number of instances that we want to actually run. Okay, now we can see one starting up. Okay, one started up, another one starts up. And now we have 2 started up. So remember what I was talking about, this orderly startup? First one establishes the cluster, the next one. So that's what was going on there. And so theoretically, we should be able to access that same database on a different port. And there we are. Now, I can guarantee that every time that we access this, we're going through round robin on the proxy. So it's going to either of those 2 instances. Okay? So let's try now then inserting into that database. Okay, and it was, oops. Let's try that again. It's on port 9001 this time. And I don't know what's happening there. My tunneling's probably not working. Oh, there you go. It's just, for some reason, taking its time. Yeah. So over here, we had 10 was the last one, and now we've got 11. And again, I can, you can clap if you want to. Yeah, he wants you to clap. So again, each time I access this, I'm going to a different instance of that thing. It absolutely invalidated the cache on each one because, and each one of those instances connected to a different database. It connected to one of those of the 3 in the cluster itself. Okay, so that was real, you know. Whew, that was close. That could have gone so wrong.
30 minutes are up.
No worries. Okay, so what have we done, Ed?
So we've made this little uni microservice a little more reactive, I'd say. I think we've proven that.
I've happily used this one. Would you?
Yeah. All right. So we got the, we've insulated ourselves against Postgres node failure. It's not just a master-slave sort of replica set.
Right.
We have multiple instances of updatable databases.
It's master all the way.
Yeah, master, right? And likewise, we've done the customer service. It's elastic as well now. We've scaled up 2 instances. We could scale that in, out. And likewise, we can do our blue-green style or canary upgrades where we bring up a new instance, new version of the application, test that out, and then start scaling down the old version as we scale up the new version, just with the same conduct interface we saw there. And we've handled our cache management issue, so we can replicate that across all the nodes and they get a consistent view back to our end users.
With very little machinery in our cluster as well. I've got to reiterate that one. No ActiveMQ, no RabbitMQ, no extended EH cache or anything like that.
And very little code modification.
Right.
We haven't had to unpurify our application and start mixing concerns or anything like that.
So although, there was, conductor was being shown there to sort of illustrate, how this can be done, this same pattern can be used, with our open source product, with Scala, Akka, and Play, as is for you guys right now. You can do that if you want to manage your own akka-cluster, right? So I just want to sort of underscore that. It's not a conductor-specific microservice. This pattern can be applied even outside of our platform, right? Because the take-home there is really CRDTs, which of course exist in other implementations as well.
Cool.
Any questions? Yes, sir.
I've got 2 questions. The first one is on the akka-data-replication clustering.
Right.
Can it support guaranteed once and only once delivery semantics? Or is it always eventual consistency? It's all of it.
No, there are no guarantees in life in distributed systems. In fact, going beyond one processor on your machine are no guarantees. So that's the first thing I'll say.
There are no notions of two-phase commit or?
No, definitely not. This is the way things are in distributed systems, meaning multiple processors on your machine as well, right? Okay. It's all a lie. Transactions are a complete lie. And so you've got to deal with the real world in this regard. Yeah, but so you get eventual consistency and you get strong consistency, strong eventual consistency. There, did I just invent a new term? Did you use that one, Jonas? Strong eventual consistency. I think we can use that one. That's what you get, right? CRDTs are guaranteed to update so long as that network between the nodes is there.
Okay. The second one is when you move from the simplistic microservice to a reactive version.
Yeah, that was quick, wasn't it?
It was quick, but you still had to make some changes to your code, right? In terms
of course.
Of your repository.
Yes.
So we come from a background of using things like Oracle Exadata and times 10, where a lot of the data replication is still very transparent to the application. So without redeploying or making changes to your code, we can move from a normal rack to Exadata. You still get the cache distributed, low latency access to data, but your application developers are totally unaware of they don't need to know about how it's done.
Yeah, I think that's a really good point. And that would continue to work here as well. I mean, there's no reason why you can't.
Ideally, it should work off configuration rather than code changes, right?
Well, I disagree. I think that I've always been a big believer in facing these problems head on. Right, trying not to abstract over the network, trying not to abstract over consistency issues in distributed systems. They're first-class problems that should be dealt with head-on. I mean, do you remember Corba, right, and RPC and all of that? Where we tried to abstract over the network, it seemed like a great programming model. We didn't then have to, as programmers, sort of worry about that kind of thing. Apart from the fact it didn't work, okay, and it's no longer with us. We have to confront these things head on, which is why CRDTs are important. They're not hard to understand. We're all very bright people, right? We get paid tons and tons of money. We should be able to handle this kind of stuff. That's my view.
Thank you.
Thank you. More questions? Come on. We got 10 minutes. Yes, sir.
More on the conductor side, I noticed that you guys can scale up nodes on demand.
Yep.
Is there a way to, or will it be a way to scale up nodes based on actual load?
Yes.
So to say, I want 10 nodes maximum or whatever minimum.
Right, absolutely. Yeah. It's interesting. I think this auto-scaling question, which I think is fundamentally about it, right? About auto-scaling. Many people seem to want this. Whether they actually need it or not, for a lot of scenarios, I would challenge. But so what we are going to do is not put that as part of the core part of conductor itself. What we want to do is treat it like a kernel, keep it small and simple, right, in its function, because it's already dealing with a complex domain of distributed systems. And through extension, by adding new services around it, then we, for example, can subscribe to its control protocol, which is RESTful, and we use server-sent events. That's how we actually handle the proxy configuration. We're using HA proxy, for example, and we subscribe. This is all external to Conductor. And we want to use those same events to receive signals from your services. We don't want to monitor these services per se, right, and observe what we think their health is. The best thing that can tell you how it's going and that understands its domain of SLA is the service itself. So we want the service itself to signal its own health, right? It's kind of like a signal saying, oh, I'm idle, or I'm getting a bit busier, I'm quite busy, I'm going to die. It's those sorts of levels of granularity. And then you can have other services in your system react to that. And then as a consequence, scale up automatically through the RESTful protocol. And in parallel, scale up infrastructure as well and integrate with EC2 or whatever your infrastructure is. Okay, so that's how we're going to approach that.
Will the API be open to development?
It is already. Yeah, it's documented. If you go to conductor.typesafe.com, conductor without the O, I have to say, then all the documentation is online and that protocol is already documented. Actually, I've got a PR that updates it significantly as well, but yeah. Okay.
Yeah, but I think that's an important point that, like with AWS ASG, you're dependent on CPU usage or back-end networking, and that's interesting, but really, the concept here is the application itself is the best judge of when it's starving for resources, right? And moving that's kind of where that monitoring and that source event belongs. CPU is interesting, but maybe not the right indicator for time to scale.
Right. Are any of you writing microservices like this? We're kind of, we do ourselves, right? We have these internally right now. Conductor is running in production within Typesafe. We're running our internal systems on it, and we deploy and manage microservices that have these sorts of problems. So we think it is a common problem, but is it a common problem? Do you guys, this use case that we presented, it sort of resonates a little bit? So how are you managing that right now? As single instances, pretty much? Or do you manage the distributed cache problem, for example? Yeah? Eureka?
Console?
Console. Right, right. Okay, cool. Yep, yep.
We use cluster sharding, and so there is no distributed case because there's only one persistent akka-persistence.
Right.
So akka-persistence plus cluster sharding, but
Yep.
we're looking into data-replication. So
Right. Right, because obviously if one actor becomes overloaded, then you want to distribute that load elsewhere as well. Right, cool. Any more questions? Come on, one more. We can do one more. Make one up, you know.
what about you mentioned the configuration, right? So you
Yes.
have one guy that's basically is first and he determines the configuration of the cluster.
Yep.
What if you have more shared configuration properties? What if you want to update them? Do you have some facilities for that?
Yeah, absolutely. So you can have, for example, one configuration applied to multiple bundles or one bundle to multiple configurations. That is up to you to manage how you want that relationship to be. And you can deploy, we didn't mention this, of course, green-blue style deployment scenario. So you can deploy, you know, your same bundle with different configurations, for example, and they will all run alongside each other, or sharing on a round-robin basis that same endpoint from the outside world as well. So you can do that, absolutely. So we do rolling upgrades in effect. And actually, the thing we're working on next is automated rolling upgrades. And again, by having the app signal its health when it's ready to, it already does in fact. So when an app starts up, it signals, yep, I'm ready. You know, and what we want to do is, the bit of work that we have to do is around HA proxy and stuff, just varying the amount of traffic, turning it up until it's 100% at the new service, and then we shoot the old one in the head kind of thing. Yeah. So.
Do you handle dependency trees, especially at the configuration level? So one service gets deployed, it exposes something, another service needs it. I deploy that, it works, but if the first service is not running, I cannot really run the second service.
Yeah.
Do you deal with that?
We do handle that, and let me tell you how we handle that. We don't believe in dependencies, okay? Because it's, again, a lie. Right? You could have service A and B, A depends on B, B starts first, by the time A starts, B's gone for some reason, right? So just deal with the fact that B might not be there at any point in time in the life cycle.
I'm not talking about resiliency, of course you have to deal with that.
Yep.
But let's say service A is Cassandra,
right.
And service B needs Cassandra.
Yep.
I want to know some configuration parameters for Cassandra that I can use, that I can use for my own services. So,
I see. Yes.
To sort of cascade stuff exposed by one service to other services.
Right, so service discovery, effectively, right? You want to be able to discover where it is dynamically instead of hard coding it in as configuration. Yes, so we do. We have a function, a service lookup function for that purpose. We actually want to enhance that as well so that we can have a service registry, which is more static in nature as well. And you can hang a lot of stuff off a service registry. Stuff for meta information, for identity management, for example, for some of those security concerns. And yeah, so we've got a few. Do anyone remember UDDI at all? Yeah. So we're not going to do XML, don't worry. But you know, there were a lot of things about UDDI as a service registry. You guys all must be really young if you don't remember UDDI. It was only like around 2000 or something, right? And you know, okay, it was all about SOAP and stuff at that time and XML and how that was going to take over the world. But some of its concepts are still highly relevant, of course.
Everybody knows that console is the new UDDI, right? I mean, we use console for the same thing.
Is it XML?
Yeah, no, of course.
Damn. Scala handles XML.
Okay, so
I think it's the last
a cache is, let's say, scalable, but one use case I have is having services that analyze real-time signals and declaring facts, like it becomes a source of truth. It declares that this thing is in a fault, this thing is whatever. So it declares things, so it's a master. You cannot run multiple instances in parallel analyzing the same data and declaring the same facts.
Yep.
Right? And the problem is that you need to detect failure and promote a new master in case the current one fails. I was wondering whether conductor has things in it that do that.
Well, it's more of a, thank you for the question, yeah. It's more of an akka-clustering sort of question in a way, though, right? Building your app on top of akka-clustering, and to that end, having members within the cluster taking on certain responsibilities. So, for example, you might use sharding to make sure that, you know, your master, you know, it's not really a master, you know, but the only thing that handles it in your cluster is, you know, this node over there. So you can certainly use cluster sharding for that purpose. You may even use cluster leadership as well as part of akka-cluster, which is a deterministic-based thing, all right, to again make sure that work doesn't get done, or to minimize the opportunity of work being done multiple times in the cluster. And you know, so the probability of that work being done in the cluster in a distributed system, full stop, and I'm talking in a very general sense now, you can make quite minimal, but you know, you can never quite eliminate it, you know, so. But yes, I think through akka-clustering you would do that. And indeed in Conductor itself, we have, you know, those sort of single point of responsibility for some things, because it's just a waste of energy to have multiple things do the same thing, if that makes sense. Thank you. I think we were out of time. So yeah, I mean, if you've got more questions, please come by and chat. Thank you.